Scorching summers are driving electricity bills higher than ever. Air conditioners run for hours, yet many homes still struggle to stay comfortable. What's surprising is that centuries ago, builders developed roofs that helped cool buildings without electricity, compressors, or refrigerants. The materials were cheap, the science worked. Some versions are still effective today. So why did the world abandon them? The answer reveals how one forgotten idea may help solve a very modern problem, and why the future of cooling might have more in common with the past than most people realize. For most of human history, cooling a home wasn't as simple as pressing a button. In hot regions, buildings absorbed sunlight throughout the day and slowly released that heat into living spaces. Summers were harsh, relief was limited, people needed a solution. Across parts of the Middle East, North Africa, and other warm climates, builders noticed something important. The roof received the strongest sunlight long before the walls did. If they could reduce heat at the roof, the rooms below often stayed noticeably cooler. That insight changed everything. Different regions created different designs. Some raised portions of the roof to create shade. Others added openings that encouraged airflow. Many used layered construction to slow heat before it reached living spaces. The details varied, but the objective never changed: keep the sun from turning the home into an oven. The remarkable part is how little technology these systems required. Builders worked with clay, stone, wood, lime, and earth. No motors, no compressors, no fuel deliveries, just simple materials arranged in clever ways. Instead of asking how to remove heat after it entered a building, they focused on preventing it from entering in the first place. That distinction sounds small. It isn't. Modern cooling systems often deal with heat after it has already entered the structure. Traditional builders try to stop the problem at the source. To understand why these roofs worked, we need to look at three simple ideas: shade, airflow, and thermal mass. Shade came first. Anyone who has parked a car beneath a tree understands the effect immediately. A shaded surface absorbs less solar energy than one sitting in direct sunlight. Traditional roofs used raised sections, overhangs, and strategic design to reduce the amount of sunlight striking critical areas. Less sunlight meant less heat. Airflow was the second piece of the puzzle. Hot air naturally rises. Traditional cooling roofs took advantage of that fact. Openings, vents, and elevated sections allowed warm air to escape before it accumulated indoors. As hot air moved out, cooler air could move in. The process happened naturally. No switches, no motors, no monthly power bill. Then there was thermal mass. Materials like clay and stone absorb heat slowly and release it slowly. During the hottest hours of the day, some of the incoming heat remained trapped inside the material itself rather than immediately entering the rooms below. By the time much of that heat was released, outdoor temperatures were often falling. The goal wasn't making the house cold. The goal was making it stable. And stability can feel surprisingly comfortable. Generations of builders refined these ideas through experience. If a design worked, people copied it. If it failed, they abandoned it. Over time, the most effective features survived. What's fascinating is how closely those observations match modern engineering. Today, engineers use advanced software to model airflow, heat transfer, and solar gain. The tools are far more sophisticated. The physics is exactly the same. Researchers who studied these traditional roofs discovered something many people didn't expect. The biggest advantage wasn't stronger airflow. It wasn't deeper shade. It wasn't even better ventilation. The real benefit appeared much earlier in the process. These roofs reduced the building's cooling burden before the cooling burden existed. Think of a leaking boat. You can spend all day scooping water out with a bucket, or you can fix the hole. Both approaches help. Only one attacks the source of the problem. Modern air conditioners are incredibly effective. They can cool buildings quickly and maintain precise temperatures, but every bit of heat that enters a house eventually has to be removed. That removal requires energy. Traditional cooling roofs approach the challenge from the opposite direction. Instead of removing heat later, they try to stop it from entering in the first place. That's why interest in these designs never completely disappeared. The science worked. The measurements confirmed it. The question is why they never became the global standard. The answer has less to do with with engineering than most people think. Air conditioning changed expectations. Once people experienced instant cooling, comfort standards shifted. Homeowners no longer wanted temperatures that felt better than outside. They wanted temperatures that felt perfect. Day or night, summer or winter, regardless of the weather. Traditional cooling roofs could reduce heat. Air conditioners could overpower it. That difference mattered. Construction trends were changing at the same time. Post-war developers wanted speed, consistency, and lower costs. Passive roof systems often depended on local climate and custom design. Air conditioning offered a simpler solution. Install the same equipment almost anywhere. Connect power. Cool the house. The formula worked in deserts, suburbs, coastal cities, and growing metropolitan areas. Convenience won. Urban development created additional challenges. Many traditional cooling systems relied on airflow, but dense cities changed wind patterns. Tall buildings blocked breezes. Crowded construction reduced natural ventilation. At the same time, traditional building knowledge slowly faded. For generations, builders passed these techniques from one person to another. As construction methods modernized, fewer people learned them. New materials appeared. New standards emerged. Older practices received less attention. The ideas survived. The knowledge became harder to find. Yet something interesting has happened in recent years. Energy demand continues to rise. Heat waves place increasing pressure on electrical grids. Utility costs remain a concern for millions of households. As a result, architects and engineers have started revisiting old ideas with fresh eyes. Not because they're nostalgic, because the physics still works. Modern projects now combine traditional concepts with newer technology. Reflective surfaces, ventilated roof cavities, improved insulation, passive airflow systems, and efficient air conditioning often work together rather than competing against one another. That's the key lesson. The future of cooling may not come from choosing between ancient ideas and modern technology. It may come from combining both. Passive design can reduce the problem. Modern systems can handle the rest. And that's the real answer behind this forgotten roof. It didn't disappear because it failed. It faded because air conditioning became the easier answer. Now, rising energy demand is forcing engineers to rethink that decision. Sometimes progress means inventing something new. Other times, it means rediscovering something old. In the case of cooling roofs, the smartest buildings of the future may borrow a few lessons from the past. If you enjoyed this investigation into forgotten engineering and hidden technology, subscribe for more stories that reveal how simple ideas helped solve some of history's biggest challenges. Thanks for watching.